So I guess I'm going to answer Saba's question there about the intermediate value theorem, the extreme value theorem, and IVT, EVT, and MVT. Yeah, intermediate, extreme, and mean. So I think it's pretty important that we understand what they're both trying to communicate. So remember, what the IVT is trying to say is essentially that between two values, it's very self-explanatory. When you think of intermediate values, when you think of two values, if a function is continuous, it means that between value, like let's say value A and value C, there's going to be a value B in between that. And I think you won't usually use it on the AP exam. It's just something that we need to know coming from pre-cal into calculus. But there is a way that you technically have to justify the intermediate value theorem. I'm going to pull it up really quickly so I don't mess it up. So usually I think you might use it on like the first or second FRQ. I don't think you'll use it, for instance, on questions about like differential equations or slope fields. It will be more so like a question about, maybe they give you a graph and they ask you to justify why there's a point in between. So yeah, so the intermediate value theorem says that if f of x is continuous on a closed interval between a and b, and if k is any number between f of a and f of b, then there's at least one value that is x equals c on the interval such that f of c equals k. I'm going to paste that because it's a little confusing. So what it basically means is that, let's say we have a curve, right? And we have one point, a comma f of a, and another point, c comma f of c. There's going to be at least one value in between this point and this point that is that c value. So that's when you'd use IVT. Then we have EVT, or extreme value theorem, and that basically just says that if f of x is continuous on this closed interval, there's going to be an absolute maximum and an absolute minimum on that interval. And if you think about it, it's just common sense. I'll paste that here as well. That is EVT. The first one is IVT, the second one is EVT. Then we'll get into mean value theorem. So mean value theorem just says that if f of x is continuous on a closed interval and differentiable on an open interval, then there has to be at least one value between a and b where the derivative of c is equal to the change in b, change in y's over the change in x's. All that means is that there's going to be some kind of value where the secant line and the tangent line are the exact same. So I'll also paste that here. And just as a reminder, a tangent line is a line that basically is parallel to the slope at some point, and the secant line connects 2 points of some kind of curve. So it's basically saying that at some point in time, the secant line is going to be basically parallel to the tangent line, if that makes any sense. Also, I don't think you said this earlier, but there's also another theorem called Rolle's theorem that is a specific subset of the mean value theorem. It just says that if f of x is continuous and differentiable, and f of a, so the curve basically has two y values that are the exact same, then that means there's going to be some number where there's going to be at some point in that curve where the slope is 0. I don't think you'll use Rolle's theorem very often either. It's just one specific part of mean value, because if you think about it, if two y values are the same, that means at some point the secant line is going to be just a straight line across. That means that similarly, there's going to be a line where the slope is equal to 0. I'm actually going to show a picture here, just in case you're confused. Actually, we'll go through these slides in a bit. So does that make sense, Saba, or was that a little confusing? Because I can re-explain it if you need it. We got another question? Okay. I'll get to Perla's question in just a second. Okay, so all intermediate value theorem says is that if a function is continuous between 2 points, there's going to be a value in between those 2 points. That's basically it. I don't necessarily remember off the top of my head when you would use IVT. It didn't come up on my exam last year. I think it came up maybe 3 years ago. That's what intermediate value theorem says. Extreme value theorem says that if you have a closed interval function, there's going to be an absolute maximum and an absolute minimum. It's just justifying that there's going to be extrema. Does that make sense at least? IVT and EVT? Okay, great. So then with mean value theorem, all that's saying, I'm actually going to exit from this if I can. Yeah. So I'm going to show a picture right here. All mean value theorem says is that when f of x is continuous and differentiable, and basically there's going to be 2 points along that curve that form a line. I'll paste it if that works. Yeah, like that. I think you can see that. Basically, mean value theorem just justifies that this secant line is going to be parallel to this tangent line. So if we have, it's just saying that the slope, so if you see from that justification, f prime of c equals the change in y's over the change in x's, right? F of b minus f of a over b minus a. It's basically saying that the slope of this tangent line is equal to this secant line, which is basically change in y over change in x. That's all mean value theorem says. I hope that makes a little more sense. And so if you look at that justification and look at this picture, it kind of, I think, helps explain it. So basically, if f of x is continuous on this interval between a and b, there's going to be this value c, right, where the slope of c is equal to the change, the slope of this point right here, so the instantaneous rate of change, the slope at that point is the same as the slope of this line. That's what mean value theorem says. So the slope at any point in this curve is going to be equal to the slope between the distance of 2 points. It's a little confusing. I completely understand, but that's okay. And I don't think it will be tested much at all on the exam because they cut multiple choice. So you should be in good shape. All right. And now I'm going to look at Perla's question. On a live stream, not 5-vol, I heard some teachers say that DE was a common abbreviation for differential equations. All math people know. Does that mean on the AP test we can use that abbreviation in explanations? That's a good question. I don't know when you would need to use that, frankly, because if you think about the FRQs, it's going to give you a differential equation like dh dt or dg dt or dy dx, right? Or sorry, dx dt or something like that, right? So I don't think you would ever have to use like DE in your explanations, because you would say something along the lines of like dh dt equals this value. So in the instance that you do have to use the words differential equations, I think diff ec, that would probably work better. I would just be wary in case your AP grader doesn't know what that means. I hope that makes sense. Okay, so I'm now going to erase this mean value theorem graph. So basically what I'm going to talk through today is just what you might see, what will be tested on the exam and what you might see on your actual FRQs. So we'll first start off with the in and out questions. Then we'll move into Riemann sums. We'll then talk about, it's going to load slowly but surely, the graph question, rate of change and separating variables, L'Hopital's rule, differential equations, and slope fields. So I guess we should start off with the in and out question. So this usually always comes up as the first FRQ on calculus AB and I think even BC. And so I know that text is really small, but you can just read this big text over here. It basically gives you an in function and an out function. So fish entering a lake was last year's question, and 2 years ago it was people entering a line for an escalator. So it basically tells you that the number of people coming in is a function and the number of people going out is a function. And you have to do a number of things, right? Because all calculus FRQs are like 4 or 5 parts, or 3 or 4 parts, sorry. And so as a result, you have to, for instance, find the definite integral of one or the other. So they say that people enter a lake, people enter a line at this function here. So for instance, from time equals 0 to time equals 300, how many people are in the line? So remember, if you are trying to find the number, when you're trying to go from rate of change to the number of people, you can answer this in the chat box, are you finding the derivative or are you finding the integral? So you're going from the rate of change to the number of people. Let's say we're trying to find the rate of change of people entering some place. So if we're trying to find the number of people that are actually in that place, are we doing an integral or derivative? Yeah, good job, guys. You are integrating. And I guess another question, if you're trying to find if the rate of change is increasing or decreasing, is that a derivative or is that an integral? Or is that the first derivative or the second derivative? Yeah, second derivative. Great job. So these are just things that you don't want to confuse yourself about. That's what's really, really concerning, because oftentimes you'll have kids who are taking these FRQs so quickly that they see how many fish enter the lake over the 5-hour period, and they think, oh, that's the rate of change. But no, that's actually the number of fish that are entering that lake. So that's where you would do the integral. You also need to make sure that you're finding a maximum or minimum using critical points. So another question, how do you find when you try and find critical points, it's when something changes from positive to negative. Is that just the function? Is that the first derivative? Or is that the second derivative for critical points? Yep, you set f prime of c equal to 0. And when the first derivative is equal to 0. Great job. How about when the rate of change is increasing or decreasing? So point of inflection, that's the second derivative, right? Yeah. So make sure that you're not confusing critical points, points of inflection, things like that. Those are really great things to review before the exam. So oftentimes on that first FRQ, you'll get a question like, is the rate of change in the number of fish increasing or decreasing at t equals 5? So at that point in time, you'd have to do, for instance, you'd have to find like you'd have to do the in function minus the out function, find that second derivative and see if it's increasing or decreasing, or if it's greater than 0 or less than 0. So those are concepts that you all need to make sure you're reviewing prior to the AP exam, even if you're in BC, especially if you're in AB. And feel free to ask questions in the Ask a Question box, just because I'm not monitoring the chat as much. Okay, so we also have Riemann sums. So this always comes up as maybe one part of a question. I've seen midpoint sums, I've seen trapezoidal sums, and left and right Riemann sums usually come up on they usually come up on the multiple choice section, but they might throw it on there this year because a lot has changed. So what you definitely need to know are your trapezoidal, midpoint, left, and right Riemann sums. And usually what you'll see on the exam is some kind of chart like this. So they'll give you t hours, they'll give you the meters per hour, and basically they'll say, create a trapezoidal sum with these 3 subintervals, or they'll say, create a midpoint sum with 4 equivalent subintervals to approximate this integral, basically. And this kind of question, you wouldn't see the acceleration part on the exam for AB just because they cut it this year, but they still might give you a chart that isn't related to velocity or acceleration, and just ask you to find a trapezoidal sum. So I guess this should be pretty easy for those of you who are taking the exam, but where my cursor is, oops, that's not what I wanted to do. My cursor is that a left Riemann sum, a midpoint Riemann sum, or a right Riemann sum? Actually, just answer like blank, comma, blank, answer, answer, answer in this order from left, middle, right. So is that right, midpoint, left? Is it midpoint, left, right? What kind of Riemann sums are they? Yeah, midpoint, but you get the gist. So, all right. We'll see. I see I have a question. Good job, guys. So let's say you have an FRQ that has a part A that you have no idea how to do, but you know how to do part B. Since we have so little time, would you recommend we chicken scratch an answer for part A and do B, but like spend time trying to do A correctly? So I think I'll answer your question. Well, actually, I'll answer Perla's question first, and then I'll get to your question. So what I would say is that a lot of the points awarded on the AP exam are really based on just like setting up things, right? So when I took BC last year, there was this polar equation question. There was like this question that I had no idea how to do, but it was asking for the integral. And so I set up the integral, and from that, like I checked the scoring guidelines later, and you get like 1 point or 2 points from just setting up an integral. Writing something as simple as the definite integral from 0 to 8 of f of t dt. That would get you a point or 2. So I wouldn't chicken scratch anything. I would try and do small steps, and if you get stuck and have no idea how to do it, move on and try and get all of the points from one part of the question. I hope that answers your question. So you want to do as much setting up as possible, and if you can't get the answer, that's okay, but you want to get as much partial credit as you can, because that's one of the great benefits of calculus, especially if you're taking A, B, and BC. Like calculus as a whole is a pretty great exam in terms of the curve. I've heard that you can get as low as a 75 or so and still get a 5. So yeah. Okay, so left Riemann sums and right Riemann sums. The way you know the difference is that, as you can see here, these rectangles, which is, remember, it's a way that you can approximate an integral. It's a left Riemann sum because it's hitting the rectangles they're using the left point as the height of the rectangle. So this is a right Riemann sum because, as you can see here, it's the right. It's like, I don't know how to put it into words, but it just kind of makes sense. The height is the point to the right. So for instance, if we were to use these four, right? Actually, this is a bad example, but if you were to have 5 intervals, you would use that left point for left Riemann sums, the first point as your height, whereas you'd use the second point as your height for right Riemann sums. And for midpoint sums, you basically find the average of the x's, find the average of the y's, and use that as your height per se. And then your width at the bottom here, or it's length and width. Your width would be the change in x at the bottom, which should be the same for all of them. Since the exam is online, Hal will be showing our work. I saw that you can upload images, is that correct? Yeah, so you can take it online. I'm sure College Board will have some kind of cool math software. Once again, it will be speculation. But yeah, you can handwrite your work and take a picture. At least that's what College Board has said so far. More updates on April 3rd. Trapezoidal, remember, the way that you calculate that is that you add the bases together, and your bases will be like this line right here. Oops, my cursor is not showing. You would take the heights and add them together. So you would like basically flip the trapezoid on its side. You would add the bases, divide by 2, and multiply by the height. And the height in this case is this, like the change in x. So you would use this formula. It's just like the formula. You literally just add the areas of multiple trapezoids. That's it. And so you'd basically create this little slope line thing between the first point and the second point and the third point and the fourth point, et cetera, et cetera. That's how you create a trapezoidal sum. Great question. Okay, so we'll move on to the graph question. This is traditionally the third FRQ on AB and BC. And usually the first of the non-calculator questions. I expect this to be on the exam because it's always been on the exam. So they'll give you a graph. It could be a graph of f prime, like it could be a graph of the first derivative, or it could be a graph of just the function as a whole. And they could tell you find the area under the curve. So remember, the way we would do that is we would take the area of this triangle, add it to the area of this triangle, and this triangle, and this triangle, and then keep approximating, things like that. So that's how you would find the area under the curve when given a graph. Or they could ask you to do the fundamental theorem of calculus. So they could say, find the integral. Let's say that this is the graph of g, and they tell you what's the specific area under the curve from 3 to 6, and that's where you'd want to do you'd want to show your work as if you were doing an integral, but you just want to show work from the graph itself. By the way, we'll be doing like live FRQ practice on these like Q&As very, very soon. In fact, I think 1 week from today, whoever's hosting this Q&A, they'll be doing live FRQ practice with y'all. It could be me, it could be someone else. And the reason why we're holding off right now, like I would love to do FRQ practice with y'all, is just because I don't know what's going to be on the exam in terms of if there's going to be 3 FRQs, 1 FRQ, 2 FRQs, exactly what kind of content. So we're holding off, I think, for all AP subjects, except for the ones where like it's like DBQ, LEQ writing, the histories. Besides those, we'll be starting next week. This is just kind of lecture style asking Q&A. If they give F prime graph, could they ask for area of F? They could say, I think more so what they could do is they could say, find, what would F of 3 be? So given this, or does that make sense? If they give you F prime, a graph of F prime, they could say maybe, like let's say this is the graph of F prime. They could say, what is F of 5 per se? I'd have to think about that. Give me like 5 seconds, and then I have to like sort it out in my brain, and I'll answer that question. Make sure that you're also know how to find maximums and minimums based on the graph or the integral of a graph. Finding the limit using graph values, that's pretty useful. And you might also see like L'Hopital's rule show up on your exam. So I'm actually going to give an example of like the FRQ from last year gives a good example of what you answer your question, Rolle. So let me see. So an example from last year, I don't know if y'all have looked at the FRQs in years past, but one question that they could ask you, for instance, is that given this graph, and they tell you if the integral from -6 to 5 is equal to 7, so using this graph literally, if they say that the integral from -6 to 5 is 7, then what's the integral from -6 to 2? So what you'd basically have to, or -6 to -2, excuse me. So basically all you'd have to do is you'd have to take 7 and subtract it from the area under this curve. So I don't necessarily think, I might have misspoke earlier, but what I mean is that they can give you a graph of F prime, and they can say, integrate it and find the value of one specific part. So for instance, evaluate like on this function, they could say, find the definite integral from 3 to 5 of 2 F prime of X plus 4. So that's where you would have to separate your integrals and then, for instance, find the definite integral of 3 to 5 of 4, things like that. I hope that makes sense. So I don't think they would ask for the area of F per se, but they could ask you for definite integrals of F. So you have 2 questions. I'm going to answer the one right here. Rolle asks, if we have like an injury that makes it hard to write, is there a way to get more time since it's been shortened? Good question. On April 3rd, I believe College Board will be announcing information about how you can get extended time policies. I know that they've been very, very accessible in the past in terms of requesting for extra time. That will be something that I would email your AP coordinator about. And also I would check the College Board page about COVID-19. They will give you more information about that. Can you review how to use the candidate test for extrema, etc.? I'm not necessarily sure what you mean by etc. I think what you're referring to is how exactly do we know if something is absolute, like to find like an absolute minimum or an absolute maximum. Is that what you mean? I think that is. So basically, the first thing you want to do is you want to list all of your critical numbers. So you want to see when you want to test for the first derivative, right? You want to see when f prime of x is equal to 0, doesn't exist, and when specifically it changes from positive to negative. Then what you would do is you would plug in certain values. I was actually going to cover this at the end, so great job for asking early. What we'd want to do with the candidate test, which I don't think we ever used that in my class. I think we call it something else. I think we always use the first derivative and the second derivative test. So that's where first you would see if f prime of c is equal to 0. And then you would also check the second derivative. If it's greater than 0, then in that case, it would be the global minimum, and it would be a global maximum in the case that f prime of c is equal to 0, and the second derivative is less than, because it would then be concave down. But there's actually another, like there's a way specifically that you can make sure that something is an absolute extrema versus just a relative extrema. So I'm going to re-explain it a little bit slower because I think that might have been a little confusing. So basically the way we want to know if something is an absolute minimum versus a relative minimum, or an absolute maximum or a relative maximum, is just checking concavity and checking for critical points. So the first thing you want to do is look and make sure that f prime of x is equal to 0, right? And that's how you determine if it's a critical point, or if it's a place where it changes from increasing to decreasing. Then you want to check the second derivative. If it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. I hope that makes sense. If it isn't, you can ask me, like, ask a clarification question, because I'd be happy to answer. Isn't the candidate test just organizing the critical and endpoints? Yeah, I think it's just checking, like, I think it's then plugging in those values and seeing, like, making a t-chart and going through the critical points and seeing which ones have the greatest y values and which one have the smallest y values. I think that's what that means. And correct me if I'm wrong. Okay. Cool. So let's also look at rate of change. So this is actually, because they took out stuff with like disk and washer method and the area between curves and things like that and cross sections, it means that questions like this are just going to be, if they exist, it's going to be separation of variables. So taking something like this complicated dh over dt equals -1/10 square root of h, and then finding the integral. So moving the square root of h to the left side and then moving the dt to the other side. Separating variables, which I think your calculus teacher should have just covered or are currently covering. Checking, once again, if rate of change is increasing or decreasing. We do that with the second derivative. And also making sure you know how to solve for that c value, given, for instance, if they say f of 0 equals 1, and then you need to separate the equation. That's how, after you integrate and you have that plus c, you can plug in 0, 1, and then solve for c, things like that. We also have differential equations and slope fields. So in this instance, these come up usually as the last FRQ. I wouldn't be surprised if it's going to be still the last FRQ on your actual exams for AB. If they give you a rate and you find the derivative of that, would that be considered a first or second derivative? Great question. That's the second. It is the second derivative, because if you're finding whether the rate of change has a rate of change that's increasing or decreasing, it is the second derivative per se, because the first derivative is that rate. Does that make sense? So let's say we have the number of people in a room. I don't have the capability to write on my screen right now, but I can show you how we would sketch the slope field. So I will do that after I explain slope fields. So make sure that y'all have like reviewed slope fields, by the way. This comes up about every other year, but sometimes it might come up 2 years in a row. We'll see what happens. So usually given a differential equation, they'll say like dh over dt equals 1/3 x times y minus 2 squared. They'll have you find the equation of the tangent line at a specific x value. So what all that means is that you are plugging in x and y and finding what you're finding the slope, and then you're using that slope to find other values using point slope form. You'll also have to find the equation of the tangent line given a differential equation. So that's separating variables, solving for c, and then finding some certain value. So as I've shown through that example, maybe they say integrate dg over dt to find g of t, and then given g of 1 equals 0, find g of 3. So all you would do is you would separate your variables. You would have that plus c at the end. You would plug in 1 and 0, and then you would find what that c value is, and then ultimately you would write it in point slope form and plug in 3. Is local linearization a part of the tangent line part? Let me make sure I'm reading that right. I would say yes. Yeah. Because what you're trying to do is you're trying to approximate a function. Yes, that's exactly what it is. Sorry, it took me a second to process that. So they might ask something like, after you using like what you see in part B in that very small font where it says, write an equation for the line tangent to the graph of y equals f of x at x equals 1, and then use your equation to approximate f of 0.7. I think that literally is local linearization, if I'm wrong. So in that instance, you can approximate some value by its tangent line. I hope that makes sense. And yeah, let's get to sketching the tangent line together. So we're actually going to look at the 2019 FRQ. So I think it's a good, or 2018 FRQ. It's loading. Let's see if I can switch screens. Okay. Thank you. Some really great paintings. It's a good place to record. Okay, now let's see if I can share my browser. Let's see if this works. Okay, great. So we have our question here, and I'm just going to use my cursor and sort of sketch it out like that. So we have this question. It says, consider the differential equation dy over dx equals 1/3 x parenthesis y minus 2 squared. It says the slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through 1, 0. So this is not incredibly difficult if you just look at what it's asking. So first you see that it wants you to sketch the solution curve that passes through 0, 2. So remember what these little lines mean. It's just saying that the slope at these values, so for instance here, the slope is 0, because remember, if the slope is like this, it's 0. If it's like this, it's undefined. And if it's like this, it's 1. And as you get steeper and steeper, the slope, so let's say we have a rate of change of 2. That means it's going to be steeper versus a rate of change of like 0.5. So first, we would sketch the solution curve that passes through the point 0, 2. Oops, my cursor is still not on the screen. Hello. So what that means is you want to take the line, you want to find where 0, 2 is, and as you can see here, the slope is horizontal. So what that means is that you want to take a line that goes straight through, and the solution curve is literally just a straight line at x equals 2. So that's the first thing we would do. Now the second thing we would do is we want to sketch the solution curve that passes through 1, 0. So we would really want to make a line, a curve that looks something along the lines. Let me see if I can screenshot this. Or actually, I'll just show it from these scoring guidelines. So what College Board wants you to show is something like this. So as you can see, that straight line right there at x equals 2. And then you would sketch it something along the lines of this. So it would go, it wouldn't ever cross into this line, but you would sketch it from here all the way up. And then it goes, it's very symmetrical. I hope that makes sense. So as you can see, we're following those slope lines. We're going like this all the way up over here. And then you would just follow, it's not like, I almost want to say it's like connect the dots, but it's not. You kind of just want to follow the path of the lines. Does that make sense, Seba? If that's confusing, we can go over it again. Okay, great. Okay, so we're going to do a quick practice run of see this, do this. So I'm actually going to paste it real quick if I can find the paste link. And for those of you in BC, you'd want to use the second link. You can look at this later. It's a good resource for calc. So let's say they tell you find the interval where f of x is increasing. Answer in the chat. How would you justify or what would you do if it's asking find the interval where f of x is increasing? What are the steps that you got to do in your head? Okay, let's be a little bit more specific. And also, you don't integrate to find where f of x is increasing. Yes, you want to find where f prime is positive. So you'd find the derivative, you would find where f prime of x is greater than 0. It's okay, everyone gets a little confused. Okay, let's keep going. How about finding the interval where the slope of f of x is increasing? What would we do then? Keyword is slope. Yeah, you'd want to find where the second derivative is greater than 0. But remember, it has to be an interval that covers f prime, and the second derivative. So yes, it's where the second derivative is greater than 0. Okay, let's keep going. How about finding, oh, we just covered this, a relative minimum versus an absolute minimum. So what is the difference? This one's a little bit difficult, but that's okay. On the right track. Yes, great job. So absolute minimums, you also have to evaluate endpoints. Relative minimums are just within a specific area in terms of critical points. You got another answer here. Relative is the first derivative test. And also there are multiple ways that you can find minimums and maximums. You can do the second derivative test. You can do the first derivative test. So when does the sign change matter? So sign change matters whenever you're trying to find when something goes from increasing to decreasing. So what I think of it as, I think sign change especially matters for inflection points. So whenever you're finding concave up and concave down, that's where you have to find where the second derivative changes signs. But for critical values, yeah, minimums, remember, it starts off, the first derivative starts off positive, or sorry, that's maximum. For a maximum, the first derivative starts up increasing, and then first derivative is positive, and then the first derivative is negative for maximums. And for minimums, the first derivative is negative and then positive. Yeah, sorry about that. And then for inflection points, remember for concave down, the second derivative is negative and then positive. And for concave up, the second derivative is positive and then negative. Hope that makes sense. Might have spoiled one of these answers now. So critical values versus inflection points, what's the difference? Answer in the chat. Yeah. Critical first derivative equals 0, inflection second derivative equals 0. And what does the instantaneous rate of change mean? Or what's another name of it? So yes, slope at a given point, which is also known in calculus terms as a what? derivative. Great job. Remember, average rate of change has been cut from AB. It's still on BC though. So that's just 1 over B minus A times F of B minus F of A. It's literally change in Y over change in X. I don't know why they cut it. And also, definition of a derivative, hint, hint, it has to do with something, or I don't know if you can write this out on your chat. It's a little bit difficult, but the definition of derivative, what does it have to do with? Do you remember? It's one of the first things we covered in calculus. It's one of the last things we covered in pre-cal. Limits, yes, or algebra 2, whenever you learned it. So remember, it's the limit. The definition of a derivative is typically the limit of, as h approaches 0, of f of x plus h minus f of x all over h. So typically on AB and even BC, you'll see where they'll give you a derivative and you have to write it in limit notation. That's usually on the multiple choice section. Or you'll see that they'll give you a limit and they'll ask you to write it as the derivative. Okay. And finally, yeah, given derivative, write it in limit form, given limit, find f of x slash f prime of x. So that concludes all the stuff that I'd covered today in the lecture. But do y'all have any questions? The answer to a limit is the derivative. Yeah, so let's say that it was like f of x squared plus h minus, or sorry, it would be like x plus h squared minus x squared all over h. So in that case, you would know that f of x is x squared, and so the answer would be 2x. Yeah, I was like, did I do that right? I hope that makes, yeah, so the answer to a limit, if it's in the structure of f of x plus h minus f of x all over h, then that's where you would answer with the derivative. Great question, Prologue. Are there any other questions? I can stay here for another like 10 minutes or so. What about the x approach A? Yeah, it's pretty much the same thing in terms, it's just f of x plus a minus f of x all over a. It's just a difference in notation. I think that's what you're mentioning. Oh, x approaching a. Sorry about that. So in that instance, you would just, so remember how you want to solve limits is, so the first thing you want to do is make sure that it actually could have a value, because if it's 0 over 0 or infinity over infinity, that's where we use what? Anyone know? L'Hopital's rule, yeah. Which, by the way, College Board made a typo last year on the AB exam, and they literally wrote it as L'Hospital's rule, which I think is really, really funny that the makers of the AP exam misspelled one of the rules that they added to AB. That's a whole different side story. But yeah, that's when you would use L'Hopital's rule. But for a regular limit, which by the way, I'm like 99.5% sure they will not put on the exam. You would want to, it depends. So if you aren't given a calculator, what you'd want to do is you'd want to find, you'd want to substitute x equals a into that limit, right? And then the limit is the value in certain scenarios. So it's difficult to explain without like an actual question, but you just want to, okay, let's look at some examples because I'm still here, right? Direct substitution ever give you an incorrect limit though? Yeah, occasionally, it just depends. So let's say, let's go with this question. So the limit as x approaches 5 of the square root of x squared plus 11 minus 6 all over x minus 5. So in this case, that's where we would do, I'm like trying to work it out in my head really quickly. This would be 0 over 0. So that's where we would start to use something, like we would try and check a variety of things. So something like these rules are pretty great in terms of, or this is just checking continuity. But you'd want to determine, when evaluating a limit, you want to try factoring. If factoring doesn't work, this is a great chart. If it loads, I'm going to link y'all to this Khan Academy article because it's a great resource. There's a flow chart of ways. That is not what I wanted to link y'all. And I think we might have a guide that's going to get uploaded on Fiveable very soon with a guide to limits, and they'll be able to explain it in a much more effective and efficient manner. But you want to start off by trying to evaluate the limit with direct substitution. If that doesn't work, then we want to see if there's an asymptote or something along those lines. And then let's see if this flow chart loads, because this is what I used in AB when I was evaluating limits. And by the way, since the test is open note, you can print this out. So first you want to try direct substitution, right? And so in the instance that it's like something over 0, then in that case, you want to check a graph or a table. If it's 0 over 0, then you'd want to try factoring, conjugates, trig identities. Otherwise, you would use like L'Hopital's rule, something like that. But if it's a real number, then usually I would say it's correct. I would say direct substitution usually doesn't fail. See, direct substitution is the go-to method. Yeah. Only in the instance where there's like a hole or something, that's where I'd be wrong. Okay, are there any other questions?